Welcome to qnawire.
For this problem on the topic of sources of magnetic fields, we are given a diagram that shows three parallel wires, each carrying a current I in the directions shown. We know the separation between adjacent wires is d, and we are asked to calculate the magnitude and direction of the net magnetic force per unit length on each of these wires. So we'll use the equation F is equal to BLI, where B is the magnetic field, L is the length of the wire, and I is the current flowing through each wire. So from here we can see that the force per unit length, F over L, can be simply written as the magnetic field strength B times the current I. So let's start with the top wire. Now for the top wire, we know F over L is B times I. But we can write B as mu naught I over 2 pi r. So this becomes mu naught I squared over 2 pi. Now there's a force acting on the top wire due to the middle and the bottom wires. So we also know that two parallel conductors carrying current in the same direction will attract each other, whilst parallel conductors carrying currents in opposite directions will repel each other. So this is 1 over d minus the separation to the bottom wire is 2d, so minus 1 over 2d. And this simplifies to mu naught I squared over 4 pi d, and this force acts upwards on the top wire. So that's our first answer. We now have the force per unit length acting on the top wire. Now the middle wire simplifies straightforward, and the force acting on the middle wire due to the top wire and due to the bottom wire cancels out. So since the forces are equal but in opposite directions. So for the middle wire, the force per unit length is equal to 0. Now finally, for the bottom wire, we have that the force per unit length again is mu naught times I squared over 2 pi into 1 minus d minus 1 over d rather, minus 1 over 2d. And so again, as in part A, this simplifies to mu naught I squared over 4 pi d, but this force is in the opposite direction, and this force acts downwards.